Let's review a two-sample hypothesis test with independent samples, but this time when we don't know the population standard deviation. So similar to our last example, we're trying to determine whether students perform better in an in-person class or an online class. You anticipate that students perform better in an in-person class. You take a sample of 16 from each class. The sample from in-class got an average mark of 80, and the sample from the online got a mark of 75. The sample standard deviation for in-class is 6, and the population standard deviation for online is 8. This should say the sample standard deviation for online is 8. You want 95% confidence. So first thing, let's organize our information. So we have in-person classes and online classes. Our sample mean for in-person is 80 and 75 for online. Our sample standard deviation is 6 for in-person and 8 for online. And our sample size is 16 for both. Now let's review our hypothesis. We believe that in-person classes perform better. So if we were to take the average marks of both, if we less sample mean, so in-person, if we were less the mean from in-person from online, we should be greater than 0 because it should be higher is what we believe, is what our null hypothesis is. Our alternative is that it is equal then or less than 0, so it either doesn't matter or it's actually worse. So now we are going to use our formula for when we don't know our population standard deviation, which looks like this. So first things we'll do is we'll review our degree of freedom. Now the formula for our degree of freedom in this example is n1 plus n2 minus 2. 16 plus 16 minus 2, or 30. This formula also requires us to determine our pooled sample variance, this right here. So we can go ahead and have a look at that. So our formula for our pooled sample variance looks a lot more complicated than it is. And we can begin filling out the information. So our sample size for our in-person sample was 16 minus 1. Our standard deviation for in-person, right? So it's delineated by 1, which we've shown as in-person, is 6 squared plus our sample for online is 16 minus 1 multiplied by 8 squared. Again, 16 plus 16 minus 2. So if we break this down, we'll see that it is 15. 6 squared is 36, so 15 multiplied by 36 is 540. And 8 squared is 64 multiplied by 15 is 960. And so we get a pooled sample variance of 50. So if we complete now our formula up here, our t with the degrees of freedom of 30 equals our sample mean of in-person 80 minus 75. Now this we have set it as 0, so we don't think there's any extra, we don't think there'll be more than 0, so it won't be 1 or 2 or more, so this would be 0. Divided by square root of 50 times 1 over 16 plus 1 over 16. So 5 divided by 2/16. 2 divided by 16 is 0.125 times 50, and we can take the square root 2.5. So let's find 2 on our t-chart. Pull our t-chart up. Now remember, we're using a degree of freedom of 30. And what we are doing is we're moving along here. And we're looking for 2. And we see 2 is just short of here. It is in between. It is in between. Now this is a one tail because this is what we're considering here. Our hypothesis is that it is greater than. So it's not that it's not 0. It's not that it can be less than or more than. It's just greater than. So that makes it a one tail when we consider our distribution. And we can see that it falls right in between here, just shy of this amount. So our one tail shows that it is 0.05 to 0.025. So probability is between 0.025 and 0.05. So now this is when we think about our probabilities, we always take the less than. So this would be the probability that it is less than. So what we would need to do is less 1 from this. So let's take it from the small amount. and we have a 97.5% probability that the information would fall in there. So in plain English, this would mean that we have a 97.5% chance that the population mean of in-person class is higher than online. And there's about a 2.5 to there's about 2.5 0 to 2.5% chance that the population mean of the online class is higher. So based on this and our 95% confidence, this is higher than our 95% confidence, we do not have enough evidence to reject the null hypothesis.